Hello, friends, engineers, and embedded professionals all over the world. Welcome to this Embedded Computing Design Roundtable discussion entitled Secure High Performance FPGAs Beyond SoCs. This is part of our FPGA Roundtable series, and this session is sponsored by Pantherun and AMD. I'm Ken Briota, Editor-in-Chief for Embedded Computing Design, and I'll be your host and moderator for today. If you're not familiar with us, please visit embeddedcomputing.com, where you'll find our coverage of anything related to the design of hardware and software for embedded systems. We're chock full of design articles, white papers, blogs, videos, podcasts, and lots more, and we're always adding new content and technology coverage. In today's session, we're going to be looking at how AMD and Pantherun together unlock FPGA solutions that outperform SoCs across industries. AMD provides silicon performance and scalability. Pantherun offers zero latency, backdoor-free encryption, and robust networking. Our speakers today are Srinivas Shekhar, co-founder and CEO of Pantherun, and Rohit Gopalakrishna, Rohit, country manager for the embedded group at AMD India. Before we get started, let me go over just a few housekeeping items for everyone here. The entire discussion is likely to take between 45 and 50 minutes. That should leave us some time to answer your questions at the end. We'll get to as many as we can as time permits. You'll find at the right side of your console window an area where you can enter your questions in real time. As I said, we'll address as many as we can at the end of the presentation. If we don't get to your question before we run out of time, someone from Pantherun or AMD will get back to you with an answer as soon as possible after the session. If you have a technical difficulty or a question pertaining to the webinar itself, like for instance, your slides aren't advancing or there's some trouble with the audio, please put that right into the question box and one of our technicians will respond as soon as they can with a fix. On the left side of your screen, you're going to see the speaker's full bios, and there's also a clickable tab that says handouts, and that's how you can download a copy of any materials that are available for this session. The on-demand version of this webcast will be available about 24 hours after we sign off today. So if you missed anything, want to go back and review or share the presentation with a colleague or a friend, you can find it again through the same link that you used to sign in today. A reminder that all Open Systems Media and Embedded Computing Design webcasts are copyrighted and may not be recorded without prior permission. One last note, make sure that you check out our weekly news show in case you missed it, in which we round up some of the biggest embedded news stories every Friday on YouTube, and its accompanying LinkedIn newsletter that comes out every Monday. Make sure you subscribe to both so you never miss any embedded technology news. I think that's enough on housekeeping and gilding of the lily. You're here to hear our discussion, so allow me to get us started. Before we jump into our roundtable, though, we've got a little bit of an introductory portion. So I would like to go ahead and bring out Rohit first to tell us a little bit about AMD and what they've been working on.
Thank you, Ken. Hi, everyone. My name is Rohit Gopalakrishna. I'm the country manager for AMD India Embedded Group. I would like to give a brief overview of the AMD as a company, and then I'd be more than happy to answer the questions that will come along based on the theme of today. Let me quickly get started. AMD has a vision. The vision is to be a high performance and adaptive computing leader in the market, solving the most important challenges of the world. Right, that is what we focus on. We are slightly more than 55-year-old company right now with more than 28,000 employees. Last year, we ended the year with $25.8 billion of annual revenue. We are definitely looking at a huge growth in 2025. We have been growing our market cap at a very rapid pace over the last few years, and I'm happy to share that currently we are in the top 25 most valued companies in the world. We operate out of more than 100 locations around the world. We have design centers based in India, North America, Europe, Asia, in several countries across the world. When you look at our growth over the last few years, our revenue has been growing exponentially since 2020, when we came out with some of the breakthrough architectures in both CPUs and the adaptive compute business. In terms of the revenue mix that AMD has, there has been a major transformation. If you look at 2019, 15% of our revenue was actually coming out of data center and the embedded business that we have had. Same in 2024, when you look at it, more than 63% of our business is coming out of data center and the embedded business. So there has been a tremendous growth in this subsegment of the company. Now, this is only possible because there's also been huge amount of R&D investment that AMD is doing in future generation architectures, both in the CPU and the FPGA SoC segment. When you look at AMD, there are four main business units that you can categorize it with. We have the data center, which is our largest business. Then we have the client computing, which is primarily focused towards laptops and handheld devices, primarily for the compute market. We have the gaming, which is focused on the gaming market. And then finally, the embedded computing business. Erstwhile, it used to be Xilinx. Now we have both FPGAs, SoCs, and embedded CPUs categorized under the embedded computing market. So what are the things that we have in the embedded computing business of AMD, right? Of course, FPGA, which is the central piece of our business unit. Followed by that, after the launch of our 7 nanometer Versal adaptive SoC product portfolio, we have the heterogeneous adaptive SoC Versal, which is also an important part of our embedded compute business. We did launch Kriya system on modules a couple of years back. Now we have the next generation of Kriya module coming in 2026. These are system on modules that are built to reduce time to market and provide ease of use for our customers. We do have our adaptable accelerator cards in the Albio series of products. And then most important product portfolio within our embedded business is the embedded CPUs, which includes the Ryzen embedded and also the EPYC embedded portfolio of CPUs. Finally, we have tried to be very innovative with mixing both the embedded CPUs and the adaptive SoCs on a single hardware platform, which we call as Embedded Plus, which is quite unique and also augments both the data acquisition capabilities of FPGAs and the compute capabilities of the x86 CPUs in a single hardware platform. AMD has more than 7,000 customers for its embedded business, and these customers are spread across diverse markets. When you look at it, our markets range from broadcast, pro AV segment, communications, which includes wired and wireless communication, industrial, vision, healthcare, and life sciences. We have aerospace and defense, which is one of our largest business segment in the embedded markets. Data center network and storage, which also uses a lot of our embedded CPUs. Test measurement and emulation focused towards the large memory testers, emulation customers, and measurement equipments, who are focused on primarily on the measurement of the signals. Robotics, which is a very hot market for us right now, includes humanoid kind of application. And then finally, automotive, which has been a growing market segment for us with huge wins that we have been having in the recent past with our adaptive SoCs. Now, this is only possible because of our multi-node, multi-generational device portfolio. Currently, we have the largest product portfolio across the market in terms of the FPGAs and SoCs. When you look at this slide, this is primarily showcasing our FPGAs and SoCs product portfolio, which range from cost optimized low-end products from AMD like Spartan, RTX, and Zinc 7000 series to mid-range, which includes ultra-scale, towards the higher end, which is ultra-scale plus. And then we have devices with integrated memories, integrated RF transceivers, and also now we are integrating AI engines into our product portfolio. So because of this wide range of portfolio, we have been able to address quite a diverse market. We are also very proud to share that AMD is in the 40th year of our FPGA business. When Xilinx launched its first product in 1985, we were pioneers in this segment. After the acquisition by AMD, now AMD is taking it forward into much higher heights. And today we are in our 40th year of FPGA. Finally, just to wrap up my initial intro slides, we are looking at high performance and computing leadership as our main vision. And we are able to achieve this with leadership foundation IP that have been built over many, many years now. We have the industry's broadest portfolio from CPUs, GPUs, FPGAs, SoCs, DPUs, multiple products for heterogeneous compute. We do have an open, proven software ecosystem ranging from Vivado, Vitis, Rockham across the board. And we have been very fortunate to have very deep and collaborative partnership with many, many partners globally, including Pantherun, which is one of our closest partners. With that, I would like to thank embeddedcomputing.com for giving me this opportunity to give me an intro slide. I'm open for questions from the moderator. Thank you, Ken.
Of course. And Shri, why don't you come out and give us a little bit of background on Pantherun before we jump into our Q&A?
Thank you, Ken. Thank you. And first of all, thank you, Rohit. It's a nice presentation, wonderfully explained about AMD, and a very, very tough act for me to follow. Pantherun, we are an FPGA-driven company. Yeah, so it's wonderful to partner with somebody with such a long track record, like 40 years, Xilinx and then AMD. Yeah. Pantherun focuses on technologies for data security, yeah, making encryption secure, easy to use, and affordable, so more and more data can be encrypted. When you look at systems today, you are seeing edge devices, things like sensors. You see cars, you see phones, you see all of the devices around us. All of this collects data, and now AI is playing a big role in all of this data to make real-time decisions. Yeah. The idea is for us to encrypt that data, protect that data, and make sure that the decisions go right. So that's where Pantherun comes in. So what do you see around us? I mean, back in 2021, we saw an attack, the Colonial Pipeline. It impacted gas supply all over the eastern side of the United States because, I mean, a system with a lot of protection, a system with state-of-the-art equipment was attacked. Yeah, it was broken into, it was taken over, and I mean, the attackers charged $4.5 million to exit the system. Yeah, so this was a significant attack. It was a wake-up call, and it happened on networks that were very well protected. So you can see what is the impact that lack of data protection, lack of network security has on systems. So what are we looking to solve? Pantherun is coming together with AMD, yeah, and AMD's programmable silicon that Rohit talked about, FPGAs. Yeah, we use them. Yeah, we build data protection or encryption that can go into edge devices of today and make them much, much more resistant to the attacks that we saw at Colonial Pipeline. Colonial Pipeline is not the sole example. We're seeing attacks day in and day out happening on our personal computing devices, happening on networks that we depend on, and that's what we're looking to eliminate. So Pantherun has built technology that can protect data in real time, that uses Xilinx's FPGA technology to build data protection across networks to ensure that there's better protection of data, better protection of networks, and attacks like the Colonial Pipeline are behind us. So how have we gone about solving it? You might have heard of an encryption technology called AES. It's the gold standard in encryption. We use AES. We build an encryption approach wherein you have much greater reliability when you implement AES. AES is a symmetric form of encryption where you require a key to encrypt. You require the exact same key to decrypt. Unfortunately, the way AES is implemented today, uh, you need a key exchange to happen to encrypt to be able to decrypt data. Hackers are sitting on networks undetected for months together. The best companies in the world are not able to find them or detect them. Yeah, and they watch for these key exchanges, and that allows them to decrypt data. So we've built a technology that's predominantly available on FPGAs from AMD, wherein you can encrypt data using a key. You can decrypt data using the same key, but there is no need for a key exchange. So a hacker sitting on the network will not be able to find the key, will not be able to decrypt data. So we make it much more secure to build our form of AES implementation. And all of this is available in FPGAs. We make sure that the encryption is seamless. We make sure that the encryption does not delay the communication. And we provide all of the communication stacks. So it allows people who are building technology, building networks, building devices around us to be able to use the FPGA, use our stacks, build a very configurable and flexible communication technology as well as an encryption technology that can protect data. And you may have heard of many such implementations of AES. They could be MACsec, which we use on local area networks in our offices, IPsec when we connect to our remote offices from outside, SSL or TLS, which we use on our browsers and our phones. All of these use AES, but they're not as reliable. They're not as efficient and real time. They're not they all require a key exchange, so add vulnerabilities. So Pantherun's approach based on FPGAs allows for a much greater protection and much greater real-time performance compared with any other solutions out there. And we're quite successful in the market. We're not a very old company, just 6 years old. Yeah. We are growing at about 5x in revenue as customers adopt us quite rapidly. We have very healthy projections for the coming years. Yeah. We are in many markets. We are in apps and SaaS related markets, CMOS video, smart sensors, industrial, and automotive. So these are all sectors that we address, all with FPGAs. Yeah, where we build the communication stacks, we build the encryption technologies, and we're growing significantly year on year. And that's very briefly what Pantherun does, and would love to keep this interaction going and answer all the questions that come to me. Thank you so much.
Absolutely. Thank you, Shri. And let's bring you back to Rohit, because I think it's time for us to jump into this discussion. Before we do, though, just want to remind you folks out there listening and watching, you can go over to that Q&A box and send in your questions that you might have for Rohit or Shri, and we'll get to those at the end of our discussion here. But let's jump right in with our first question, and this is for you, Rohit. Can you give us an overview of AMD and specifically in high performance computing and embedded, just really quickly to sort of ease us in?
Sure. So, like I mentioned in my slides, we are a high performance and adaptive computing market leader. We are basically a chip company. We develop CPUs, GPUs, FPGAs, and SoCs focused on diverse markets. It can be automotive, industrial, robotics, defense, aerospace. But like Shri also mentioned, the underlying thread across all these different, whether it is silicon or software that we do build, is the security piece, right?
Mm-hmm.
We do have hardware security and software security, but primarily we also are uh, adaptable and reconfigurable, which means that partners like Pantherun can actually build their algorithms on top of it without having any latency built into it. So
Yeah.
our primary focus is to build chips which help partners to build solutions on top of it and provide it to the customers.
Absolutely. And Shri, can you give us some more details on that? Like how does Pantherun use AMD's embedded and HPC capabilities in your Pantherun security products? Sort of how does that partnership work on a sort of technological front?
Sure, Ken. I mean, let me put it this way. Yeah, when you look at technology today, you have things that run in software. Yeah, we all we use bigger and bigger processors as we run software-based solutions. Yeah, and I mean, we accept that software is a sequential process, so there are certain delays involved. Yeah. So when you have a processor, you run a large piece of software, you get certain performance, you get certain latency with it. Yeah. Now, when you decide that you need to do things in real time, what that means is that you need to have something that responds within a very, very specific amount of time. It is difficult to do that purely in software. Yeah, it is required to have certain hardware intervention. Yeah, and AMD, I mean, is a perfect platform to work on. Yeah, they provide hardware-based acceleration. They provide silicon that is configurable. Yeah, so it's a company that's built high performance hardware, silicon. Yeah, and it's also built silicon that you can program, yeah, to work like silicon, but it's something that you can program in the field. So it's flexible to build solutions on. Yeah, and that's what an FPGA is. And we use an FPGA, yeah, because it allows us to function like with our technology for data protection, yeah, with on silicon. So you get the kind of performance that you would normally expect from a chip. Yeah, but you don't need to tape out chip. You don't need to worry about the performance. You can program your designs into the chip, yeah, and it will perform like a chip. But the best part about this is that you put your phone there on the network, or you put your switch there on the network, or you put your IoT device there on the network. Yeah, and you get attacked by hackers. Yeah, you can go in there and reprogram the chip depending on how the hacker is attacked. Okay, so this is all possible in the field in real time. Yeah, so
Yep.
you see how the attack is happening. You decide that, okay, this is how I can protect the network, and you can go and reprogram it on the fly. Yeah, and that is the strength of technology that AMD, in Xilinx 40 years, yeah, that doesn't come easy. Yeah, and
Yeah.
that's what they built, and that's what we leverage, and that's how we build our solutions.
Yeah. So this session is about high performance FPGA beyond SoC. So let's get spicy, Rohit. I'm throwing it at you. Why are FPGAs better than SoCs for secure high performance systems? I mean, SoC's been sort of the standard for a long time.
Sure. So see, basically, when you look at when you look at this high performance compute systems, next generation systems, they of course require security. But if you're logged into a fixed function SoC, right, which is having fixed number of functions that you can build into it, then basically it's going to be very hard to achieve security, like Sri mentioned, because security is changing, right? The threats are changing on a very dynamic level. So AMD's adaptive SoCs and FPGAs basically add massive parallel logic. We do have hardened crypto engines, of course, but on top of it, the reprogrammable compute blocks that we provide helps partners like Pantherun to actually build their own, I would say, zero latency kind of engines. So essentially, they are able to implement like a full line rate encryption and have advanced networking, whether it is TSN or 10 gig Ethernet or 25 gig Ethernet, without being constrained by a fixed SoC architecture, right? They can be
Mhm.
very agile as they're building systems for different customers. So that is the reason why we are able to achieve this with our AMD architecture.
So I'm not doing my job if I don't ask the question that all the SoC people out there are going to ask. What about OTA? Doesn't that solve that problem for SoCs rather, where they, there's a new security threat, we'll just push an update. We'll push an update. Doesn't that sort of solve it?
Yeah. So when you say over the air updates, again, you will only be able to do on certain types of updates that you can provide. You cannot completely change the persona of the device, which might be the need of the hour sometimes when the threats are coming in at a dynamic rate, right? You cannot completely change the function of the system itself. When we provide our reconfigurable device, you can essentially change the complete functionality of the system to change from one type of a persona to another type of a persona, right? So
Yeah.
because of that, OTA is much more constrained and very rigid in terms of its functionality. What we call is dynamic function exchange, right? So dynamic function exchange is where you can actually change the complete function into something much bigger than just a simple update.
Yeah, it's a little bit like an SoC requires you to prognosticate and tell the future, whereas an FPGA just lets you change the thing when the future shows up. Shri, can you tell us, staying on the same tack here a little bit, where out in the field, Pantherun and you have seen traditional SoCs fall short in these arenas of high-speed networking and security, just to sort of nail the point home?
Sure, Ken. Ken, let's look at two types of products. One is a switch. Yeah, so you connect a switch, you connect a bunch of devices to it. Yeah, and they all exchange data with each other. Yeah, likewise, you can connect a gateway to the switch, a 4G gateway. Yeah, and you stream the data to the internet. Yeah, that's a typical IoT application. Yeah.
Sure.
Now, this switch, you can build it with an SoC. So commercial off-the-shelf COTS SoC. Yeah, you build the switch, functions beautifully. You don't need to think about anything at all. Now, you come to an attack scenario, okay, wherein you have somebody who's querying devices across the switch. Yeah, and that device, it could be a man in the middle type of attack or a replay attack. You're querying the device, you get information, you store it, you pass something else on, and so on. Yeah. Now, the switch wouldn't be able to do anything. The COTS silicon on it won't be able to do anything. The only way to do anything is to send somebody out there, pull out that switch, okay, put something else there, yeah, and then you disrupt the whole operation of the plant, which is doing communication, which is doing controls, which is sending data to the internet, and so on. Now, if you instead had a FPGA there, yeah, instead of a SoC, you had an FPGA there, one of the Xilinx devices there. Yeah, what would you do? Yeah, you wouldn't need to change the device at all. You would say that, okay, there's this particular IP address. I do not send it information. Yeah, you could hardwire that FPGA to say that this particular port, I block it. I allow data to come in. I don't allow data to go out. So suddenly the switch, yeah, becomes another, cybersecurity device, which we call the data diode. Yeah, there is one-way communication. There is no communication back. Yeah. So this is the configurability that a networking device can gain from if you just choose to remove the SoC, plug in the FPGA. Yeah. And we're not even going into the performance benefits. I mean, if you can today compare an SoC, yeah, you can compare its communication capabilities. You can compare its efficiencies in communication. There's no comparison with an SoC. Yeah, the kind of throughputs that you can achieve on networking and communication, switching, and so on an FPGA are significantly better. So not only do you get better, more efficient communication, you get the greater flexibility to be able to change the device into something that doesn't even resemble its previous, for want of a better word, maybe avatar.
Yeah. Um, so, and both of you guys feel free to jump in on this. Are there any sort of concrete advantages that engineers are going to find that you've observed when moving critical functions into FPGA fabric? Because a lot of the time, I think it's probably fair to say folks are going, if they decided to go in this direction, would be migrating from an SoC into an FPGA fabric. What advantages have you seen that they're going to find? And either one of you, please feel free to jump in.
Sure. Srinivas, I'll probably share some inputs and you can add on to
Sure.
it.
Yeah,
So
sure.
when you migrate from an SoC into an FPGA, naturally for most of your audience who are very well knowledgeable in the FPGA domain, one of the main thing that they are going to get is the parallel computing capability, right? The data compute is parallel compared to a serial based compute that happens in a typical a fixed function SoC. That is the main advantage. Followed by complete reconfigurability of the device, which is essentially you can change the complete device persona in the field from one type of a function to a completely different type of a function. That is another advantage that you get compared to uh, any of the fixed function SoC. And lastly, I would also like to add um, the security features that are built into adaptive SoC or an FPGA that we build. So we actually build. When we look at security, we basically talk about three different types of securities, right? One is the anti-tamper features, which is basically protecting the customer IP or sensitive data, so that you can avoid, cloning or reverse engineering, things like that. The second one is the information assurance, which is protecting the customer's data itself, and making sure that there is nobody has filled around it with that data. Now this comes with cryptography like AES encryption, and we also have methodologies like fault tolerant designs or isolation design flow. These are all ensured. These are all implemented on our FPGAs to ensure information assurance. And finally, the trust feature, right? The trust feature is basically to give a confirmation that the silicon itself is Trojan free, right? That means you have to have silicon vendor approved bit files on the device. Otherwise, you cannot put any sort of a firmware or a software or IP onto the device and make it work, right? So this is basically what we call as the trust feature. So all these three things are implemented, and on top of it, we have security algorithms from partners like Pantherun, which adds a completely different level of security on top of it. at the line rate, this is where we see benefits compared to a fixed SoC.
And Shri, did you have
Srini,
anything you wanted
feel
to
free
add
to add.
there?
Yeah.
Uh, uh, Very hard to add something once Rohit has had a go. Yeah, I mean, he's really given it a, I mean, he's covered it in great detail. Yeah,
Hmm.
I think, I mean, when I look at the way, I mean, I compare SoCs and FPGAs, uh, I think. There's no level of I mean of description we can give to feel programmable. I mean the distance that FPGAs have traveled today, I mean from just being test devices, yeah, for people who were designing silicon, tested on an FPGA, tested on a reference board that Xilinx provided with the FPGA, yeah, and then go and tape out their SoC. Yeah, you will be surprised that that model is completely changed. 40 years, I think, Rohit, you people have done a wonderful job on changing that
Thank you.
mindset. Yeah, yeah. The way products are designed today. Yeah, Ken, I wouldn't be surprised if pretty much a large portion of devices have FPGAs doing controls. Yeah. Now, if you look at I mean, a car, I mean, when you look at the electric cars, I mean, there isn't so much of distributed architecture anymore on an electric car. Yeah,
Yeah.
everything is centralized in a gateway. Yeah. Now, that gateway today is very, very complex. Yeah, it needs to have, I mean, inputs from cameras coming in. Yeah, it needs to have various kinds of, I mean, inputs coming in from, I mean, the drive systems or the doors and things like that. Yeah, the lidar system and so on. Now, all of this today comes into a chip, yeah, which has to take all of these inputs. Yeah, there are ultimately a lot of other devices, other chips on that same board. One does a CAN interface, one does a video interface for the cameras, one does, I mean, some other automotive Ethernet interface and so on. Yeah, these are all silicon that, I mean, make a design very, very complex. Yeah, they make the operating system that needs to control that communication device very, very complex. You need to have all kinds of real-time prioritized communication, MMUs, and so on. Yeah, more more software you put there. Yeah, with due respect to all the software people who are listening in, I mean, more you put there, I mean, more bugs there are. I mean, more crash testing you need.
Shots
Yeah,
fired.
yeah. So yeah, if you could just put an FPGA from AMD in there. Yeah, I mean, it comes with an SoC. Okay, it comes with the programmable logic. Yeah, so you could put IP for CAN bus out there. You could put I mean, Ethernet IP there. You could put I mean, and you could prioritize all of these things, inside that chip to run in parallel.
Hmm.
Yeah, and you would process all of that data, pass it on to the ARM core within the same FPGA. Okay, can you imagine how much simpler that hardware will be? How much less loaded the software will be? Yeah, how little MMU you need on that OS. Yeah,
Hmm.
and I mean, you could simplify the design. You could I mean, reduce the bill of materials. Yeah, it would probably make I mean, I mean, maybe you can bring in AI to design that board for you. Yeah, you wouldn't need actual designers to do it. But I mean, I'm maybe trivializing it a little bit, but I think FPGAs are the way to go, and you will see them happening more and more and more. It's not any more test equipment. Yeah, it is real productionizable designs, and then you add the security part of it. You add the configurable security. Okay, you really do have winning technology here.
Yeah, I think so. And uh, I'm just keeping an eye on our time, so I want to make sure that we get through as many of our discussion points as we can. So Shri, I'm going to ask you to keep the flow going here and tell us a little bit about the AMD features that you at Pantherun are using to shape the way that you design layer 2 and layer 3 security specifically. I mean, AMD's got so many security features that are available. Which ones are most important for you guys, and how are those informing your layer 2, layer 3?
So when you look at communication technology, layer two is, is at wire speed. It is less software, a little more of hardware. Yeah. So what we do is we will leverage AMD's Emacs. So all their Ethernet related functionality we use. Yeah. So we take data that comes over an Ethernet port. Yeah, we use the AMD Emacs, all their IPs for that. Yeah, so we're able to look at packets. We're able to identify the MAC addresses within the packet. We build all the logic for parsing that packet. Yeah, so anything that comes at layer two, which is about 50 odd protocols that we've implemented, process on the we so all of that happens on AMD with some of the IPs that they provide. Yeah. Then you have layer three. These are more higher level protocols. They require the software to process. Yeah. So what we do is we pass them on the portion of the same FPGA chip, which has a lot more
Sri,
Shri,
yeah.
sorry to interrupt you, Shri. It sounds like we've lost your audio.
Sorry.
Oh, you're back. We lost your audio for a second there,
Yeah.
Shri. Sorry about
Okay.
that.
I'm sorry about that. Yeah. So we take a layer three data. All of that goes into the ARM cores on the FPGA. So we utilize every portion of what AMD offers us in the FPGA. Yeah. Some of it builds out all the layer two protocols on the programmable logic side, and then we do the layer three protocols on the ARM side.
Yeah. Now, Rohit, you're not gonna stay off the spotlight for that long, because AMD is well known for especially your sort of speed and the power that offers the zero latency or low latency solutions that everybody's looking for, especially at the edge. And can you tell us a little bit about how AMD does that? What are some of the ways that you help folks get that secure networking at 10, 100 GP gigabits and even more now these days? It seems like it never stops going up at this point.
Sure, sure, yeah. So I think the question basically is, what kind of hardware features do we provide for the zero latency secure networking application, right? So essentially one of the key technology in this entire thing is the SerDes technology that we built, the serializer, deserializer that are integrated into the FPGAs and SoCs that we make, and also the hardened crypto engines, to terminate all these different, whether it is 10 gig or 25 gig, or even sometimes 100 gig links, which process the packets, the data packets in the hardware, right? When I say hardware, in the PL, the programmable logic. Now, on top of it, Pantherun basically will add their stealth encryption IPs, which Srinivas talked about, and the layer two, layer three networking, pipelines, that operate at, I think it operates at the wire speed, encrypting the full packets without changing the packet format or dropping the throughput. So essentially, customer gets the complete security which they are looking at, without any, additional stress on the CPU load. Which, when I say CPU, I'm talking about the ARM APUs, and also the no latency built into it, right? So
Yeah.
these are the main few features that we have with this transceivers or hardened crypto engines. That is what basically gets used for achieving the zero latency application that Pantherun is trying to do.
I'm gonna keep it on you.
Ken, if I can I just add one small point there, if you don't mind?
Of
Yeah,
course.
I think I missed that. Yeah, I used to build switches before with SoCs. Yeah, my previous company for about 6 years did this. Yeah, and we did very well. Yeah, and then I mean, we thought that we would build the same thing with FPGAs, and you will be surprised, I mean, compared with any SoC in the market, a switch with an FPGA, yeah,
Mhm.
can improve throughputs by about 7-8%.
Incredible.
Port to port, yeah, yeah, it can improve throughputs by about 7-8%. We've experienced that. Yeah, our switches with FPGAs communicate so much better than the ones with SoCs. So we've data for it. It's proof that's available in the market. Yeah,
Yeah.
that is one thing. Yeah. Second, very important thing today is that when you look at the government sector, if you look, if some of our listeners are working in the government sector, yeah, if they're building out solutions with SoCs, it's a hard sell in some cases because governments don't trust SoCs that come from some other country.
Yeah.
Yeah, for
Correct.
want of better words. Yeah, whereas an FPGA circumvents that because you can take technology that we built on an FPGA. Yeah, governments or agencies can look at that technology. They can make sure that something called a backdoor doesn't exist. Yeah, you can never be sure on an SoC. Yeah, so this is, I think, an important point that I'm sorry I missed mentioning. I think
Yeah.
that's very valuable.
No, I think that's critical. I mean that at as more and more systems are making use of FPGAs, they're being used in high security situations, sensitive situations. So it's important to note that FPGA has the advantage of being, for lack of a better way to say this, it's sort of being a green field when you get it. It's got nothing there until you program it, until you layer it in. Um, Now, I mentioned this before, and this is relevant to what you were just saying, Shri. As we think about the future and future proofing, how and Rohit, I'm going to ask you to take a swing here first. How is AMD building uh, to future proof? I mean, we've got we're hearing about quantum computing and post quantum, and how is AMD building to be future proof against those kinds of innovations that we haven't even seen the impact yet?
Sure. Yeah, absolutely right. I mean, quantum computing is the future, and which also means that there's going to be attacks happening using quantum computers. So we need to go figure out how do we safeguard our data and networks against those attacks also, right? So basically, typically when you look at a traditional SoC, right, like a fixed function SoC, which we have been talking about, it typically hardwires the crypto, right?
Mm-hmm. Yeah,
It hardwires the crypto, which means that once the standards change, and standards are continuously evolving, and if we don't even know what are the standards for the quantum computer based attacks yet,
yeah,
right? So there is definitely going to be change in standards, which often requires a silicon spin if it is a fixed SoC, right?
right,
So with our FPGAs and SoCs, the hardware data path and even the cryptographic schemes that we are talking about are fully field reconfigurable, right? So customers can update their what we call as the post quantum cryptographic algorithms, right? That's what we have been talking about,
yeah,
and newer protocols through bitstream and firmware updates, and when you have Pantherun's architecture, like for example, if they're building the kind of products that their IP that they're building is designed to be very crypto agile, right? So on top, this will be on top of it. So the same platform can evolve from like a pure AES only deployments, like AES being the gold standard, like Srini mentioned in the beginning of the session, to I would say like a hybrid uh, hybrid classical plus a PQC, because we are looking at a existing AES encryption support plus post quantum cryptography encryption standards towards a full PQC deployments tomorrow, while extending the life cycle and extending the longevity of the products that you are already having. We are not changing the hardware here. The hardware stays same. We are just adding more and more security features on top of it. That is the advantage of having AMD adaptive SoCs, which are future proof
Yeah.
at this point, right?
So that's the capability. Shri, let's talk about the concrete in the field. How is Pantherun preparing your own architecture for post quantum threats on AMD platforms? I mean, is reconfigurability a big goal?
Sure, Ken. First of all, honestly, nothing we can do that works without the silicon being safe. Yeah, when a chip boots, yeah, it is at its most vulnerable. Yeah, and on an FPGA particularly, you're loading on an IP or whatever the chip has to function. Yeah, at boot time. Yeah, I know for a fact that there are a lot of regulations coming into play for silicon to be quantum safe. There are a lot of quantum related algorithms that are being defined as well. You have crystal dilithium, you have crystal kyber, you've got Sphinx plus, and so on. And you know, I mean, I can't reveal a lot of details, but I know that AMD is at the forefront of all of this innovation. Yeah, they are, they're people who define this kind of technology. They're really the leaders. Yeah, so the silicon is very well protected. Yeah, allows us to function without fear. Yeah, for the future. Yeah. Now, once the chip boots up, yeah, there isn't that much more that the chip can do. Yeah, the rest comes into the purview of the Pantheruns of the world. Yeah, so then we need to build AES in a way that is more quantum safe. Yeah, today the biggest weakness of AES or any form of encryption today is that it requires a unique number or a key, as we call it, yeah, to encrypt. Yeah, you need, particularly with AES, you need the exact same key to decrypt. Some other forms use a related key, but you need a key to encrypt, you need a key to decrypt. And this is all maths. The key can be the same, yeah, or the key can be different. Yeah, but the key has to be related because you're using a key to change a set of numbers. You need to use either the same key or a related key to change back the numbers. So that's encrypt and decrypt. Yeah. Now hackers, as they sit on networks, they are able to see this key exchange. Yeah, and a quantum computer at some point is going to be an aid to a hacker. Yeah, so you give it a key exchange, no matter how complex you make the maths around that key, yeah, it's going to break it. Yeah, so the only solution is don't give it a key exchange. Don't tell it that this is the key or this is a relation to the key that I use to encrypt or decrypt. So that's where Pantherun comes in. We are building technology wherein you can use AES. Yeah, you can have the comfort of the security of AES. AES is considered 100 man-year effort to break if you don't have the key. Yeah, but it's nice to say you don't have the key, but then you go and share the key across the network. Yeah, we avoid that. We build ML technology that generates keys dynamically. Every packet has a unique key that we don't exchange. Yeah, at the destination, the key is generated by itself. Yeah, independent of how it was generated at the source, and the decryption happens. So there is no key exchange. So anybody listening in, be it a quantum computer, be it the best hacker in the world, I mean, a lot harder if you don't have access to the key exchange. Yeah, so that's something that we've done. We are peer reviewed as a quantum safe approach. Yeah.
Yeah.
Another thing we've done is when you look at network packets, encryption technology today changes how the network packet looks. Yeah. So anybody listening in can see, okay, this is encrypted using TLS. This is encrypted using IPsec. Yeah.
Yeah.
Whereas we don't change data format. Yeah. So encrypted and unencrypted packet looks the same. So again, no inputs to somebody listening in. So these are ways in which we do our bit to be quantum safe, and then we depend on AMD to do things on the silicon.
Yeah, and it's the lack of exchange of the key is really key, where it's really important. I think as we think about these future security problems, the old story about the greatest vulnerability in any system is the fault that exists between the keyboard and the chair. And that you're trying to circumvent that. Although I did appreciate the way that you didn't issue a challenge to the security world by saying that it's unbreakable. That's we don't want to get people out there saying, oh really. But as we get here near the end of our discussion and get close to the end of our time, I just want to sort of bring us up to the highest possible level here and sort of ask you both to sort of wrap us up and talk a little bit about adoption and markets and where you see the most early adoption of FPGA secure networking and for high performance especially, and where whether in India or globally, where you guys are sort of seeing these systems already going into the field and what markets you think they're going to be most impactful in. And Rohit, why don't you answer us first?
Sure. So when you look at the kind of adoption that we are looking at for this kind of a market, the strongest pull actually is in the mission critical, latency sensitive applications. It can be automotive, in vehicle and roadside networks. It is industrial automation, which is time deterministic industrial automation. It can be defense grade secure communication, which also uses this kind of data. It can be applications like railways, where Pantherun has been doing a great job right now. It can be power grid, which is another area of vulnerability that we see. It will be high speed enterprise and edge networking applications. In all these areas, basically when you look at it, customer, what do they want? They want to consolidate functions. They want to hit higher and higher throughputs, whether it is 10 gig or 25 gig or 100 gig. While doing that, they want to meet and evolve. They want to make sure that they are evolving to the security standards and the compliance requirements. That is where we try really hard to provide a scalable silicon platform which is reconfigurable. On top of it, of course, we are fortunate to be partnering with Pantherun, who provide all these extremely good IPs, which goes on top of it, right? So that is where I see the adoption, Ken.
What about you, Shri? What have you been seeing in terms of early adopters?
I really, I agree with Rohit. Industrial is a sector. Yeah, I think it's a strength of AMD as well. It is,
Yes.
We honestly ride on their strengths. I'll be honest with you. They are AMD, we're Pantherun. Yeah, so we ride on their strengths. Industrial is one of their focus areas. Networking, I think, is a big area of focus for them. They extend right from the edge all the way to data centers. I mean, you saw Rohit's presentation on how their data center business has grown and how much I mean, they impact that business. So you see higher throughput systems. I mean, I think I mean, FPGAs have a very, very big market there. So we're seeing those focus areas. So networking, telecom, industrial, yeah, automotive is certain areas of automotive are very, very strong place for FPGAs. I think more need to be, yeah, but that's a work in progress for I think AMD and its partners like us.
Mm-hmm. Yeah, absolutely. And I think that's a great place for us to wrap up. This is a big conversation that could go on for hours and hours, but I'm afraid that is the end of our time for today. Folks out there, if we didn't get to your question, I know we had a lot to talk about, so we didn't really get to any of the questions that you've been sending in. One of the folks from Pantherun or AMD will get back to you as soon as they can. They're going to get all of those questions. And so check your email. Remember, you're also going to be receiving in your email a link to the archive of this presentation so you can view it again later. I'd like to thank Rohit and Shri for the great discussion, and to both Pantherun and AMD for sponsoring this event. And of course, none of these discussions and conversations that we get to have here would be possible without you out there watching and taking part and asking questions, our engineers and developers and professionals throughout the embedded computing space. So thank you all so much for attending, and I hope you all have a great day. Thank you again, Rohit, and thank you, Shri.
Thank you.
Thank you.